Okay, welcome to another video on finding the derivative using first principles. This time we're going to look at f of x is equal to 1 over x. Let's get into it. Again, as always, we start out with the limit definition. So we have f prime of x is equal to the limit, again, as h approaches 0 of f of x plus h minus f of x all divided by h. And then here we plug in 1 over x for f of x. So an f of x plus h. So we then have this. And again, as I keep mentioning, always keeping the limit notation until we finally drop it at the end when we use a direct substitution. So we then have the limit of 1 over x plus h minus 1 over x all divided by h. At this point, so similar to the previous videos, there's usually some kind of algebraic manipulation that you do. In this case, hopefully the most obvious thing to do is to combine these as one fraction and then proceed from there. So we do as such. So we have the limit as h approaches 0. Here, we're just multiplying, again, the top and bottom by the corresponding denominator. So we get x minus... So we get, we multiply x, we effectively multiply x and x here, and then x plus h and x plus h here. So in the numerator, we really have x minus x plus h in brackets. So we actually have x minus h. And then, oops, that should be here. Let me rewrite this. So you have x minus h. Again, this is all divided by x times x plus h, and then that is all divided by h. So another way you could write this is 1 over h times this. It doesn't really matter how you do it, but regardless, in the next step, we will effectively be bringing that up, because again, we remember dividing by anything is the same thing as multiplying by the reciprocal. So this fraction divided by h is the same thing as this fraction times 1 over h. So next we have, again, limit as h approaches 0. In the numerator, the x's cancel out. So in the top, we just have negative h. And again, this h in the denominator gets multiplied to the top fraction's denominator. So divided by, I'll write it out like this, but hopefully you do also see that you can directly do that. But yeah, so you have xh, or x times h times x plus h. Here, the h's cancel out, so you're left with negative 1 on the top. And yeah, so here, I'll write out the final step before we do our direct substitution. So we have, I'll write the negative out front. So negative 1 over, then x times x plus h. And then finally, at this step, we do drop the limit notation because we are doing our direct substitution. So we then are just left with negative 1 over. We have x times x plus 0. Which is obviously just negative 1 over x squared. And as usual, if we use our the power rule, quotient rule, division rule, not division rule, but product rule, anything we do know in terms of derivative rules, you can also verify that this is indeed correct. So if you say you had f of x is equal to 1 over x, which is again the same thing as x to the negative 1, you can then apply power rule. So prime of x, again, you bring down the power and then you decrease the exponent by 1. You have negative x to the power of negative 2. And then, of course, you can rewrite this as a rational number or a rational expression. So you have negative 1 over squared, and that agrees with exactly what we solved for down here. Okay, perfect. Thank you for watching.